equivalent EMF of two different cells when they are in series. So here we have two cells E1 and its internal resistance is R1, and other E2 internal resistance R2 are connected in series. So in that case, net V will be equals to E1 minus IR1 plus E2 minus IR2. So voltage up to here, if suppose I current is passing through it, so according to Kirchhoff's law, this V will equal to E minus IR1 plus E2 minus IR2. So that means here it is E1 plus E2 minus I R1 plus R2. So that means here you have E equivalent minus I R equivalent. So E equivalent is E1 plus E2 and R equivalent is R1 plus R2 as they are in series. So very simple, the EMF will be added, that is E1 plus E2, and since the resistance are also in series, so they will get added in series R1 plus R2. So equivalent will be E equivalent will be E1 plus E2 and R equivalent will be R1 plus R2. Now equivalent EMF and equivalent internal resistance of a combination of two cells when they are connected in parallel. So here we have E1, here it is R1, and they are connected with in parallel, that is E2, and here it is R2, and finally this. So if we just try to find the equivalent EMF, so here we have V equals to, for this circuit only, E1 minus I R1, equation number 1. And to consider for this, since the current is flowing this way, so it is here V will be equals to E2 plus IR2, because current is going from positive to negative terminal within the cell. So this is equation number 2. If we equate them, so we have E1 minus IR1 equals to E2 plus IR2. So here we have E1 minus E2 equals to I R1 plus R2. So then I will be equals to E1 minus E2 upon R1 plus R2. Now putting this value of I in either equations 1 or 2, so let us take first equation. So that time putting value of I in equation 1, so we get V equals to E1 minus E2 upon R1 plus R2 into R1. That means V equals to E1 into R1 plus R2 minus E1 R1 plus E2 R2. So here we have E1 R1 plus E1 R2 minus E1 R1 plus E2 R2. Just see once again. V equals to E1 minus I R1. Putting value of I1 here, E1 as it is minus I. I is E1 minus E2 upon R1 plus R2 into R1. Taking LCM, E1 into R1 plus R2 minus this whole divided by R1 plus R2. Similarly here, it will be R1 divided by R2. So E1 R1 will get cancelled and simply we'll get V equals to E1 R2 plus E2 R1, this is 1, upon R1 plus R2. If I multiply it by R1 and R2 and divide also, then what adjustment happens? It is here, this get associated with this and this R1 R2 here, so you will get E1 R2 upon R1 R2, so it will come E1 R1 plus E2 upon R2 into R1 R2 upon R1 plus R2, and that is nothing but 1 by R equivalent equals to 1 by R1 plus 1 by R2, that is R1 plus R2 upon R1 R2. So converting this R1 R2, this is R equivalent. So here you can say E1 by R1 plus E2 by R2 into R equivalent. So this is the E equivalent equals to E1 by R1 plus E2 by R2 into R equivalent. So this is the E equivalent and R equivalent is 1 by R1 plus 1 by R2 as they are in parallel. Just see again, V equals to E1 minus E2 upon R1 plus R2 from the value of I into R1. So here E1 into R1 plus R2 LCM लिया, minus open कर दे bracket E1 R1 minus gets plus E2 R1. It is not R2, it is R1, and divided by R1 plus R2 as it is. Then opening this, E1 R1 plus E1 R2 minus E1 R1 plus E2 R1. E1 R1 will get cancelled. So you are left with, divided by R1 R2, E1 will left with E1 R2 plus E2 R1 divided by R1 plus R2. I have just made some adjustment, multiplying and dividing by R1 R2 here. So associate this R1 R2 with this and this R1 plus R2 with this. So here we get E1 by R1 plus E2 by R2 into R1 R2 upon R1 plus R2. This is nothing but the R equivalent is 1 by R1 plus 1 by R2. So that is R1 plus R2 upon R1 by R2, and just reciprocal will be R equivalent. R equivalent equal to R1 R2 upon R1 plus R2. So this is the R equivalent. So you can multiply it by simply R equivalent. So then E equivalent will be equal to E1 by R1 plus 2 by R2 into R equivalent.